Okay, imagine this. You take a $20 bill, right?
Mm-hmm.
And you just throw it away.
Ouch. Okay.
Now, imagine doing that like over 300 million times every single year.
That's a staggering amount of money.
It really is because, well, that's basically what America's doing. We're tossing over $6.5 billion worth of perfectly good recyclable stuff. Paper, aluminum, plastic.
Just piling up in landfills instead of being reused.
Exactly. It really makes you look at that blue bin a bit differently, doesn't it?
It absolutely does. And, what people often don't see is just how much it costs and honestly how dangerous it can be to handle all that household recycling.
Dangerous? How so?
Well, beyond the cost, we're talking hundreds of millions annually just for sorting in the worker's face, some pretty hazardous stuff.
Yeah, I read about that. It's not just like gross things like dirty diapers, which is bad enough.
Right.
But they find things like old surfboards, broken TVs, even incredibly hand grenades sometimes.
Hand grenades. Seriously.
Seriously. It just shows the human risk in a system that honestly could be way more efficient.
It really highlights it. And then you look at the overall picture. The U.S. only recycles about a third, maybe 33% of eligible trash.
Only a third. Wow.
Yeah. Compare that to, say, South Korea or Germany. They're recycling over half their waste. It just shows how much potential we're leaving on the table.
But it's not just a matter of people not trying, is it? The system itself seems kind of messy.
Oh, definitely. You've got over 9,000 different local recycling programs across the country.
9,000? No wonder it's confusing.
Exactly. There's zero standardization. So you see these massive swings in recycling rates state to state. Like California and Oregon are doing okay, around 37%.
Okay.
But then you look at Mississippi or Louisiana, and they're down at like 8%. It's just fragmented.
Right, a patchwork. And that fragmentation, that was a problem even before the China situation, wasn't it?
It was a challenge, yeah. For, decades, really, we relied heavily on shipping our recyclables overseas, especially to China.
How much are we talking?
Between 1992 and 2017, over $11 billion worth went just to China. But a lot of it was, let's just say, not perfectly sorted, contaminated.
Okay.
So when China put its foot down in 2017, basically banning imports of contaminated recyclables, the national sword policy, it threw the whole U.S. system into chaos.
Because suddenly there was nowhere for all that mixed stuff to go?
Precisely. Facilities lost their main market overnight. It hurt their bottom line, and unfortunately it meant more stuff ended up back in landfills. It showed just how, reliant we were on that export valve.
Okay, so you've got high cost, worker safety issues, pretty low recycling rates overall, this confusing patchwork of programs, and then the global market upheaval. It paints a pretty challenging picture.
It does. The current system clearly isn't firing on all cylinders.
This is maybe a tech solution brewing. That's what we're digging into today, right? AI and robotics stepping in.
Exactly. This is where things get really interesting. Companies like AMP Robotics are emerging, and their whole mission is basically to use AI and automation to fix these problems. Make recycling safer, much more efficient, and, crucially, economically viable.
AMP Robotics. I read the founder, Matan Horowitz, spent something like 6 years developing this.
Yeah, 6 years of R&D. And the basic idea, described quite simply in one source, is robots with, like, a little piston that just flicks things off the conveyor belt.
Yeah, it sounds simple when you put it like that. Flicks things off.
Right. But obviously there's some very sophisticated tech behind that flick.
I bet. So let's picture it. What does one of these high-tech facilities actually look like? AMP1 in Cleveland, Ohio, right?
That's their flagship plant, yeah.
Yeah.
And the description from Kevin Page, who works there, is pretty striking. He called it basically an entire robot itself. Very little hands-on sorting.
An entire robot plant. Wow. And it processes how much?
Around 200 tons of recyclables every single day. Material coming in from all over the eastern U.S. It's a huge step up in automation.
200 tons a day. Okay, so walk us through it. What happens when my recycling bin stuff arrives there? How does the robot plant sort it?
Okay, so it's a multi-stage process. First up, a big rotary magnet pulls out all the ferrous metals, iron and steel, think baling wire, old car parts maybe, steel food cans.
Got it. Magnetic stuff first.
Then they use air jets. Powerful streams of air blow the lighter materials like paper scraps, flimsy plastic packaging, films off the line.
Okay, magnets and air. That sounds somewhat familiar from older plants too. Where does the AI really come in?
Right here. This is the core of it. Cameras everywhere, constantly watching the conveyor belts.
Feeding images to the AI.
Exactly. Feeding images into AMP's deep learning neural network. Think of it like a brain that learns from data. It sees a lot of data.
How much data are we talking?
The AI reportedly scans and analyzes over 50 billion images of objects a year.
50 billion.
Billion. With a B. It's basically this super advanced garbage sensor that learns to identify all sorts of materials, even when they're, as one source vividly put it, smashed F and folded and dirty and inconsistent.
So it can tell a crushed Coke can from a crushed Pepsi can, or a specific type of plastic bottle even if it's mangled.
Pretty much. And it's adaptable. They can tweak the AI to target specific materials, even specific colors, depending on what the market wants at that moment.
That's incredibly useful. And they monitor the whole plant, right, for jams and quality?
Oh yeah, constant monitoring. Plus, they have this clever recirculating line. If the system isn't sure about an item or misses it the first time,
it gets another chance.
It gets sent back around for another pass through the sorters. That helps them hit a really high capture rate. They're aiming for 85–90% of the target materials.
And the goal for the final product, the bales they sell?
The goal is super high purity, like 90% or more. That's what the recycling mills need to make quality new products.
Okay, so it's highly automated, very sophisticated AI. Is there any room left for humans in this sorting process, or is it all robots now?
There is, actually, and it's a fascinating part of the system. It's sort of a human-AI partnership.
How does that work?
Well, even this advanced AI isn't perfect. Sometimes it gets confused or misidentifies something. When that happens, images of those tricky items get flagged.
And sent to
human annotators. Many are based in India, apparently. These humans look at the image and provide super detailed feedback.
Like, no, that's not just plastic. That's HDPE, plastic, blue, milk jug.
Exactly that specific.
Yeah.
Type, color, form, sometimes even the brand. This feedback loop constantly trains the AI, making it smarter and better at handling the sheer variety of trash.
So it's like humans are teaching the robots, refining their skills. Best of both worlds, maybe?
For landfill.
Speed of AI, nuance of
For
human
most of
sight.
America's
That's a good way to put it.
recyclables,
Now,
this is
the
their
big
only
question,
chance
of
to
course,
avoid being sent to the
does
dump.
it pay off? Is it actually cheaper to run?
Yeah, the economics. What does AMP say?
They claim their system, with the AI and needing far fewer human workers on the sorting lines, can be up to 50% cheaper to operate than a traditional MRF.
MRF.
Sorry, materials recovery facility. That's the standard name for those sorting centers.
Okay, a potential 50% saving. That sounds really significant.
It is a big potential advantage.
But okay, even if you sort everything perfectly with 90% plus purity, you still need someone to buy that sorted material, right? That's still a hurdle.
That is the elephant in the room, yes.
Oh.
Joe Castaner from AMP brought this up. You can sort it perfectly, but if there's no stable market, no demand for certain materials.
It doesn't matter how well you sorted it.
Exactly. He mentioned number one plastics that's colored, like maybe green soda bottles or something. Often, there's just very little demand for that specific stream.
So it could still end up landfilled, even after all that high-tech sorting.
Unfortunately, yes. And the simple economic truth is sometimes, especially when oil prices are low, making brand new virgin plastic is just cheaper than recycling old plastic.
Ugh, that's frustrating. Which brings us to this idea of EPR, Extended Producer Responsibility. Can you break that down quickly?
Sure. EPR basically puts the responsibility for managing a product's end of life, its disposal or recycling, onto the company that made or sold it.
So the manufacturers pay or help manage the recycling?
That's the idea. It incentivizes them to design products that are easier to recycle and helps fund the infrastructure. But it's not widespread in the U.S. yet. Only about 5 states have EPR laws specifically for packaging.
And what does AMP think about EPR?
They see it as important, definitely a step in the right direction. But they also argue that technology like theirs is crucial to really move the needle. They talk about needing to double our current recycling rates, and they believe AI and robotics are key to actually achieving that kind of leap.
So for AMP, it's not just about building sorting plants, it's about making the whole recycling system more profitable, more attractive.
Precisely. Their bigger vision seems to be making recycling and waste management genuinely economically sustainable. If it's profitable, they argue, then investment in infrastructure will follow, globally even.
Which could help tackle bigger environmental problems, like plastics ending up in the ocean.
That's the hope. Make recycling work better financially, and you unlock the potential to really scale it up and reduce pollution.
Okay, so wrapping this part up, it really feels like AI and robotics offer a powerful new toolkit for U.S. recycling.
Definitely. Tackling contamination, inefficiency, safety risks.
Yeah.
All at a scale that's hard to imagine with purely manual sorting.
But we need to remember, it's not a silver bullet, right? Tech alone won't solve everything.
Absolutely not. You still have those market forces. Someone has to want the recycled plastic or paper. And policy, like EPR or other regulations, still plays a huge role in shaping the whole system.
It makes you think, though. We're throwing away billions in value, causing environmental damage. If this tech can handle the sorting side so much better, what else needs to change? Like, fundamentally, how we consume stuff, how things are designed and made in the first place. Could those changes, combined with the tech, finally get us to a truly circular economy?
That is the million-dollar question, isn't it? Or maybe the $6.5 billion question. How do all these pieces, technology, policy, markets, and our own habits fit together? Definitely something worth mulling over.
It really is.
A complex puzzle.
Well, if you found this look into the future of recycling as fascinating as we did, be sure to like, comment, share, and subscribe for more interesting conversations.